Hi, here we are again doing another Stroke Buddies, Stroke Survivors Support Group meeting. And this morning we've got Dr. Hetzler back for the 7th time. And he's going to do a presentation on consciousness, the soul, religiosity, and the brain. And I think this should be really interesting. He has a little PowerPoint presentation he's going to give us. And so, Dr. Hetzler, why don't you go ahead and share your screen and take it away?
Okay, thank you, Ralph. I will do that. And I am happy to answer questions at any point along the way because some of this might be a little confusing. And I apologize, but my goal is to challenge you. Your brain responds to challenge, and I think this will be a challenge. So we'll get started here. There we go. Can you all see that?
Yes, sir.
Okay. So that's the title, and that's me. Whoop. These are the topics that I will deal with. The mind-body problem, René Descartes, what the frog's eye tells the frog's brain, Blindsight, the split brain, Phineas Gage, Oliver Sacks and the soul, religiosity, and the temporal lobe. So, without further ado, we'll start with the mind-body problem. From the earliest historical times, people have believed they possess something intangible that animates them, a mind, a spirit, or a soul. It stems from the fact that each of us is aware of his or her own existence. But what is the nature of this spirit or soul? Is it physical and tangible, like the rest of the body? Or is it a spirit that will always remain hidden? This puzzle is called the mind-body problem. There are two general approaches to the mind-body problem. One is called dualism. That is, the mind and body are separate. The body is made of ordinary matter, while the mind is not. The other approach is called monism. The mind is a phenomenon produced by the workings of the brain. Neuroscientists take a practical, monistic approach. And this way of thinking can be traced back to René Descartes, a 17th century French philosopher and mathematician. Here's a picture I took of him when I was young. René Descartes, like most philosophers of his time, Descartes was a dualist. He felt that each person possesses a mind that is uniquely human and not subject to the laws of the universe. However, he was the first to suggest a link between the human mind and the brain. He believed that the mind controlled the body, and the body, via sense organs, supplied the mind with information. The transfer of information from the mind to the body and vice versa occurred via the pineal gland, a small organ on top of the brainstem. In his view, the pineal gland served as sort of a little joystick, although he didn't use that term because the joystick wasn't invented then. But with slight movements of the pineal gland altering the body by altering the flow of cerebrospinal fluid. Now that shows the location of the pineal gland. Now normally it doesn't light up like that in the brain, but that's where it is. As a young man, René Descartes was greatly impressed by the moving statues in the royal gardens that were just west of Paris. If someone approached the statue of the Greek goddess Diana, that person would step on a stone that would alter the movement of pressurized water moving at the base of the statue. That would cause Diana to run and hide behind a rose bush. I can still remember going with René to that and watching that, and he was really in awe at that. And there's a picture of Diana, the huntress. These devices in the royal gardens served as models for Descartes in theorizing how the body works. This was the first time a technological device was used as a model for explaining how the brain works. In the 1940s, when there were large telephone switchboards, it was thought that the brain worked like a switchboard. Later in the 1960s and 70s, where computers were first developed, it was thought that the brain worked like a computer. We turn to blindsight. Does consciousness reside in the brain? So-called blindsight has implications for our understanding of consciousness. Blindsight is the ability of people who are blind because of damage to the visual cortex. The visual cortex is located at the back of the brain, the very back. It's in the occipital lobe, and I will show you a picture of that in a while. But anyway, even though they are completely blind, they can still respond to visual stimuli that they cannot consciously see. Take the case of patient Mr. J. A stroke left him almost completely blind, and he walked with a cane. On a visit to the physician, he sat down, and the doctor took his cane. He was asked to reach out with his right hand and point to what the physician was holding. But I can't see anything. I'm blind, said Mr. J. I know, but please try anyway, said the doctor. Mr. J pointed and looked very startled when his finger touched the end of the cane. How did that happen? How is blindsight explained? Well, the eyes send information to several parts of the brain, an old part and a new part. The old part is the primitive visual system at the top of the brainstem. It controls eye movements and brings attention to sudden movements. This old part can control body movements. And this is where a frog's visual system ends. There's a classic paper published in 1959 called What the Frog's Eye Tells the Frog's Brain. Turns out there are special cells in the frog's primitive visual system that send messages only when there are small, quick-moving dots. These are called bug detectors. The message goes to the frog's tongue, directing it to capture the bug. This part of the visual system is still active in patients with blind sight, but it is not a conscious part of the brain. Blind sight, therefore, tells us that consciousness is not a general property of all parts of the human brain. Everyone following this so far?
Yes.
I'll take silence for a yes.
I said yes.
Okay. Now, the eyes also send information to a new part of the brain, which has connections to the speech areas of the brain and what we think of as thought. This new part of the brain includes the thalamus. Now, I put in parentheses lateral geniculate nucleus because the thalamus is divided into several portions, each involved in a different function. And it is the lateral geniculate nucleus that is the visual portion of the thalamus. The lateral geniculate nucleus of the thalamus sends visual information to the visual cortex at the back of the brain to the occipital lobe. That is the human brain. We are looking at the left side, the left hemisphere. Now, if you look at the image on the left, you can see that the human brain is divided into 4 separate lobes. Now, again, these are not color-coded in the human brain. They're just color-coded here for reference. At the front of the brain is the frontal lobe. Behind that is the parietal lobe. Under both of those is the temporal lobe in green. At the very back of the brain is the occipital lobe in yellow. The occipital lobe is where you see. This shows the human visual system looking down on top. See the two eyes at the front and the two visual fields, one for each eye. So the left eye has a left and right portion, and the right eye has a left and right portion. The left portion of the visual field is in blue. The right portion is in red. Now, they are not labeled L and R for left and right in this diagram. Rather, they're labeled N and T. The N stands for nasal. The T stands for temporal. So the nasal part of the visual field is the part closest to the nose. The temporal is a more lateral or outside portion. On the right, you see damage that is done to damage anywhere along this visual pathway. Now, leaving the eye, you see going down there, is the optic nerve. That exits the eye, and the optic nerve from each eye meets at the optic chiasm, right in the middle. Axons then leave as the optic tract, that's solid blue on the right, solid red on the left, and the optic tract goes to the thalamus. Now, I previously mentioned that the thalamus has separate portions, and it is the lateral geniculate nucleus of the thalamus that's involved in vision. Now, both Ralph and I had a stroke in our right thalamus, but neither of us have permanent visual deficits because of that. And that is because our strokes did not involve the lateral geniculate nucleus portion of the thalamus. In the thalamus, there is a synapse, and then axons leave the thalamus and go to the visual cortex in the occipital lobe. That pathway going from the thalamus to the visual cortex is called the optic radiation. And damage to the optic radiation can therefore cause visual problems. Now, how might the optic radiation be damaged? Well, the optic radiation goes from the thalamus to the visual cortex, and it goes through the parietal lobe to get there. But it's below the surface of the parietal lobe. Let's say you have a tumor inside your parietal lobe. How is a neurosurgeon going to remove that? Well, he has to cut into the parietal lobe to get to the tumor. And in so doing, he has to cut through portions of the optic radiation. And therefore, you can have permanent visual field problems on the opposite side of the brain as a result of this. So if the right optic radiation is cut into, you'll have a permanent problem in your left visual field, permanent blind areas, which would prevent you from ever driving again, for example. Any questions here? Okay. Now, this is the new visual system that humans have. This is another view of the visual system. You see the eyes at the front, the optic nerve labeled ON, the optic chiasm, the optic tract labeled OT, and on the right-hand side, you see LGN for lateral geniculate nucleus. That's the visual part of the thalamus. And then the optic radiations going on to the visual cortex. But you also see the superior colliculus, more towards the middle. There are axons going there, and that superior colliculus is the older part of the brain. That's where the frog visual system stops, and that's the part of the visual system that someone with blind sight would still have and could still direct the movement of their hand to touch an object. We move on to the so-called split brain. If consciousness resides in a certain type of brain tissue, is it possible to cut this tissue in half, creating two separate consciousnesses? The short answer is yes, it is possible, and it has been done. The two cerebral hemispheres constitute the largest part of the human brain. They receive information from the opposite side of the body, and they control the movements of the opposite side of the body. So the right side of your brain controls the movement of the left side of your body, and it receives sensory information from the left side of the body, and vice versa. The left hemisphere controls speech. The right hemisphere cannot talk, it is mute, but it is autistic and musical. On the left-hand side here, you see the human brain looking down from on top. It's called left brain, but that's really left hemisphere, the left side of the brain. The so-called right brain is the right hemisphere. You see the eyes in front of the brain looking out, and you hear the left visual field and the right visual fields are shown. Information in the right visual field goes to the left side of the brain, which has the language center. So it is the left side of the brain that can read. The left visual field goes to the right side of the brain, which cannot read. Okay? The corpus callosum is a large band of fibers or axons that interconnect the two hemispheres so that each side knows what the other side is doing. It ensures that our actions and thoughts are coordinated. The corpus callosum can be cut in half, can be severed down the middle of the brain. And that results in two separate consciousnesses within the same skull. This is sometimes done in order to prevent a seizure in one side of the brain from going over and engulfing the other side of the brain, for example. Patients with a so-called split brain say that their left hand seems to have a mind of its own. Now remember, if that person is talking, it is the left hemisphere or the left side of the brain that is doing the talking, because the left side of the brain controls speech. For example, if a person with a split brain is holding onto a book with both hands and reading, they will report that the left side of the brain, or the left hand, tries to put the book down while the right hand continues to hold it. Why is that? The left hand is controlled by the right hemisphere, and the right hemisphere cannot read, so it's bored by this and tries to put the book down. The right hand, which is controlled by the left hemisphere, is holding the book in place so the left hemisphere can read, and it holds the book in place. This shows a severed corpus callosum. This is a coronal view cut from the top, like you were slicing a stick of salami or something. And that shows the corpus callosum severed at the top there.
Looks more like head cheese. Bad dad joke.
Oh, good joke. Yes, that would be head cheese. Okay. Moving on, there's one case of a man with a split brain who was trying to hit his wife with one hand and protect her with the other hand.
Wow.
Did he really want to hurt her? Yes and no, depending on which side of the brain we were talking about. The split brain reinforces the notion that we become conscious of something only when it reaches the speech centers of the left hemisphere. What about personality and any questions on that before we move on to another topic?
Yeah, quickly. That makes me think, like, how does that affect people with aphasia? If everything has to go through that language center and you have aphasia, does that cause consciousness or
Well, aphasia results from damage to the left hemisphere. So it is the left hemisphere that talks. It's the left hemisphere that understands speech. And there are different types of aphasia. When we talk about aphasia, we usually mean problems talking, but it could also be problems understanding.
right?
And that all deals with the left hemisphere. Okay, well, what about personality and emotions? We're going to learn something about the role of the human brain in personality and emotions by looking at the curious case of Phineas Gage. Phineas Gage was a railroad worker in 1848 in Vermont. He set off explosive charges in large boulders. In one instance, the detonation occurred early, that is, before it was supposed to, resulting in a 42-inch long, 1.2-inch wide metal rod blown straight up through his skull and out the top of his head. The left-hand side here shows his skull with the rod going through it. His skull and the rod are currently housed at Harvard University. The right side is a computerized reconstruction of how his brain was affected. The red pole goes through the frontmost part of his frontal lobes. That's called the orbitofrontal cortex. And that seems to most likely have been the only part of his brain that was damaged.
Did it damage his left eye?
Actually, no.
Huh.
Phineas Gage never lost consciousness and suffered little or no pain. He was awake and alert when he reached Dr. John Harlow 45 minutes later. He had a normal pulse and normal vision. And following a short period of rest, he returned to work several days later. But he was not the same person he was before the accident. After the accident, Gage became a nasty, vulgar, irresponsible vagrant. His former employer refused to rehire him because he was so different. Gage's personality, reasoning, and capacity to understand and follow social norms had been diminished or destroyed. He found it virtually impossible to get a job. The only job he had of sorts was to be part of P.T. Barnum's sideshow. He would be in a tent, seated on a chair with the bar that went through his brain, and he answered questions about the accident.
I guess they sawed it off.
No, it went all the way through.
I mean, but did they leave him with 42 inches of metal rod?
No, it went through his brain and exited the top of his skull and landed in the ground behind him. See,
Oh, okay. So it
it was an
wasn't
it was an explosive charge. You see, what happened with the group he was working with is they would drill a hole in a large boulder. Gunpowder would be put in, and then something like straw on top of it. And Gage's job was to take this tamping iron and push down on the straw before a fuse was lit to ignite the gunpowder. But one time, he thought that the straw was put in, but it wasn't, and he tapped the gunpowder with his iron, and that set off a spark that ignited the gunpowder, causing the rod to go up through his head, out the top, and on the back.
okay. When you see the pictures, I still have the rod there. So it went all the way through.
That's correct. Went all the way through and out the
Okay.
top of his head. Now, 20 years later, his doctor, John Harlow, perceptively correlated Gage's behavioral changes with presumed damage to the frontal lobes of his brain, and he published that. But Dr. Harlow's writings were completely ignored. No one in the scientific or medical community paid any attention to it. That was unfortunate because this was the time when Paul Broca in France was being lauded for his work on aphasia, which is often called Broca's aphasia. So why was Broca lauded but Harlow ignored? Because Broca had a brain. He had the brain of his patient, whom he called Tan, because Tan was the only thing that person could say. And Broca could show where in his brain, Tan's brain, had been damaged. But Harlow did not have Phineas Gage's brain. Unbeknownst to Harlow, Phineas Gage had died months earlier, and he had been buried along with the bar. So since Harlow did not have a brain, he was sitting around singing, "If I only had a brain," but he was just ignored. Okay. We now know that the bar destroyed his orbitofrontal cortex, an area that helps us use our emotional reactions to guide our behavior. So damage to this part of the brain results in poor decision making. This part of the brain actually does not fully mature until about age 25. So we're relatively poor at making good decisions until this part of the brain is matured. And by maturation, I mean myelination. Most neurons in the brain have a coat of myelin around the axon. And when that myelin is fully formed, that's when that part of the brain has matured. And that's when the person can use it completely. And in humans, that does not occur until we're about 25 years old. And it turns out people with antisocial personality disorder have reduced size of this part of the brain. What about the soul? We've discussed some aspects of consciousness, but what about the soul? To gain some insight into this, we turn to Dr. Oliver Sacks' book, The Man Who Mistook His Wife for a Hat. That's the title of the book. Here's the cover of the book. This is a book I used in one of the classes that I taught at Lawrence University. Two of the cases in there involve chronic alcoholism. Alcoholism may cause Wernicke-Korsakoff syndrome. This is characterized by confusion, disorientation, and confabulation. What is confabulation? Well, that is the tendency of the person to basically make up things that he or she can't remember. They just fill it in. They confabulate. They're not intentionally lying. It's just that since they can't remember it, they just fill it in with whatever comes to mind. It's not intentional lying. In later stages, the person remembers the remote past, but almost nothing of what goes on around him or her. There were two cases of Wernicke-Korsakoff syndrome. One was called a matter of identity, described Mr. Thompson. Mr. Thompson would misidentify Dr. Sachs as a dozen different people within 5 minutes. He never knew who or where he was. He continually improvised a world around him, that is, he confabulated. He treated his brother as unreal. The capacity for feeling was gone, and Dr. Sachs felt that he was de-souled, that is, he no longer had what we think of as a soul. Another case was titled The Lost Mariner, described the case of Jimmy G. He was admitted in 1975 at the age of 49, but he thought it was 1945 and he was 19. This was a man without a past or future, stuck in a constantly changing, meaningless present. Dr. Sachs asked the sisters in the Catholic nursing home if they thought he still had a soul. They said, "Watch Jimmy in the chapel and judge for yourself." Dr. Sachs did that and was profoundly moved, watching Jimmy kneel and take the Holy Sacrament. According to Dr. Sachs, Jimmy did find his soul in the chapel. It had not been lost. What about religiosity? By religiosity, I mean strong religious feelings or beliefs. In 1983, a paper was published suggesting that mystical and religious experiences result from micro-seizures in the temporal lobe of the brain. You might recall that the temporal lobe is located on the side of the brain, sort of inside from the ear. Here, this shows the brain. Again, you can see the temporal lobe in green there. And they felt that abnormal activity in the temporal lobe caused religiosity. Epilepsy has been associated with religious fervor since the time of Hippocrates. I can still remember Hippocrates talking about that in one of his forums. In fact, some people believe that the visions and deep spiritual experiences of several famous prophets, including Ezekiel, Buddha, Muhammad, and Joan of Arc, may be epileptic in origin. In 2015, a case of a man with a history of temporal lobe epilepsy who reported to the emergency room with hyperreligiosity after he stopped taking his medications. After medications were resumed, he returned to baseline, no longer displaying this hyper-religiosity. And here we have the brain. One of the wonders of the known universe, still a mystery after all these years. So that is my talk about consciousness, the soul, religiosity, and the brain. I hope your brain understood this and appreciated it.
Do all you can with what you have, in the time you have, in the place you are. Do all you can. Do all you can.